this is my third report on my subject Calculus 2, the continuation on defining the limits. So now let's discuss about the indeterminate form. So this form is common in calculus, and the limit definition of the derivative is the limit of an indeterminate form. So let's begin. So definition, the indeterminate conveys the idea the limits cannot be determined without additional work. So it is an expression involving the two functions whose limit cannot be determined solely from the limits of this individual function. It means that in the indeterminate form, it is the two functions that cannot be defined. So that we need to add more value, or we need to add more strategies to find the limits, the value of that limits. So let's start with the first form. So we have the form of infinity over infinity. This indeterminate form is after applying limits, we get infinity over infinity, we can be solved. There is no proper solution for this fraction, and that is why we included it. It is an indeterminate form. So the best example for this is this one. Limit of n, quantity of 2 plus e over x, raise x over the 3x as x approaches to 8. So we cannot figure out what is the answer of that example, so we can come up with the infinity over the infinity. The second one is the infinity minus the infinity. Sorry, that is minus the infinity po. And then there is ambiguity in the equation. So you cannot minus infinity from infinity. That is the rule. We cannot minus the infinity over from the infinity. So let's have an example. Limits of 1 over x as x approaches to 0. So minus to our 1. Limits of x. Limits of 1 over x minus to 1 over sin x as x approaches to 0 is equal to 1 over 0 minus 1 over 0. That is the value of our 1 over 0 is infinity, and minus to our 1 over 0, that is infinity. So that is how we call the infinity minus the infinity. The third one is a 0 over 0. This is a common indeterminate form. Dividing any number by 0 is undefined. It could be any value. The reason is that the division will not be completed. You keep dividing the numerator with 0 until we keep going to infinity. So the best example for this one is this one. If we need to find the 0 over 0. Limits of x over 1 minus a raised to 0 as x approaches to 0 is equals to 0 over 1 minus a raised to 0 equals to 0 over 1 plus 1. So we can copy up 1 plus 1 is 0. So copy the 0 here, and 1 plus 1 is 0. So this is the answer, 0. That is our 0 over 0 indeterminate form. Next is the 0 times infinity, where the answer is undefined. It could be any number that we can't predict. So this is the example. Limits of x and x as x approaches to 0, positive, right? So we can come up with 0 and quantity of negative infinity. The next one is the 0 raised to 0, or the 0 to the power of 0. This problem is similar with the division by 0. Mathematics rules say that any positive number besides 0 whose power is equal to 0 will be equal to 1. Yes, that's right. For example lang kung ito yung 0 over 0 na hinahanap natin. That is the example. And then the next one is the infinity to the power of 0. Infinity value doesn't have a universal value. Infinity having a power equal to 0 is also undefined. So this is the example. Limits of x raised to x as x approaches to 0, right? Positive, right? And that equals to e n x over to x. The next one in the last one in their indeterminate form is the 1 to the power of infinity. Since we don't know the value of infinity, so the example is this one. So limits of quantity of 1 plus 1 over n raised to 3n as n approaches to infinity is equals to limits of quantity of 1 plus n quantity raised to n, quantity of 1 plus 1 over n is raised to 3. As n approaches to infinity, we can come up with the answer of E3. So that's how to know or to determine the indeterminate forms for solving our limits. Thank you. I hope you have learned a little. So hope you see you on my next video. Thank you and goodbye.